Every morning when you're staring at your big, beautiful face in the mirror, getting ready for your day, maybe you're wondering, how does it actually work? How do you see yourself? And Mr. Jesse Miller is here to answer that age-old question.
Well, sort of. I'm not going to answer specifically how a mirror works.
Okay.
Well, I mean, I can, but I was going to tell you how they make those mirrors.
How you make one.
How you make those mirrors. Actually, today, modern mirrors are made by depositing aluminum onto a glass surface, and then they that aluminum reflects back. But we're going to show how they did it, and they still do it today in the high-end mirrors, how they did it in the Victorian era.
Sure.
Before that, the Romans used to pound silver foil and gold foil and attach it to glass, and that was mirrors, but they didn't reflect quite as well as this, and you're going to see this. We call this a Tollens reaction, or a Tollens test, a reaction in chemistry, and you can actually do this at home. There's recipes on the internet on exactly how to do this. Basically, you need some silver nitrate, which is a little bit expensive, but it's not too bad. Some lye, or sodium hydroxide, and dextrose, which is sugar. Okay.
Okay.
And what we're going to do is first we're going to mix some silver nitrate and ammonia together. This is going to be a little smelly. Sorry.
It's almost like a taste test. A, B, C, D.
That's right.
Go for it.
Which one's the silver nitrate?
Right. So we mix these two together, and that causes the silver to go into a complex that we call silver. Well, it's a complex with ammonia. Now, the problem with this, and the reason why I waited until now to mix this, is because this can be explosive. You know, we're Cynthia when we need it, right?
Moment,
no,
well, Drew, I'll just stand back.
Well, it can form an explosive silver azide. So this is not stuff that you want to just leave sitting around once you've mixed it. You want to get the reaction to completion.
Sure.
We're safe right now.
Okay.
But if I was to leave this overnight, it could form silver azide crystals and explode when we touch it. But it's not going to do that now. This is a sugar solution. This is sugar and some tartaric acid, and that is going to act, our sugar is going to be what reduces the silver from this ammonia complex into elemental silver. So we'll add that, we'll add the silver nitrate and ammonia, and then in order to get the reaction really going well, we need to add some sodium hydroxide. So we'll add that, and once we get that, you see it's turning brown. It turns brown right away.
Pretty.
Brown and black. This is from the silver turning to silver oxide, and once it goes from silver oxide, it dissolves further into another ammonia complex, and then eventually that gets reduced down to elemental silver and deposits itself onto the inside of the glass, well, in the inside of the beaker, onto the surface of the glass. It takes a little bit, so we'll just continue talking while we're doing this. Like I said, nowadays they do this with aluminum. It's not the same reaction, but it's much cheaper than silver is. But this forms a really, really nice reflective surface. You can see it starting to form already.
Oh, wow.
Okay, it looks black, but now you can start to see that it's reflecting.
Yeah, you can see the light shining off of it. And
if we were actually making a mirror, what we would do is we'd have a flat table, so to speak, and we'd put this reaction on that, and then once it was formed, you'd wash it, dry it, and then you'd affix some adhesive to the back of it so it didn't stay in place and flake off. Right.
Jesse, you must use a shake weight at home. You got that down.
Yeah.
This looks really cool, actually.
It is. It's a lot of fun.
Wow.
And as you can see now,
oh, wow.
It's just like magic. But it's not magic. It's chemistry, right?
It's science.
It's science. There we go. All right. So now we can see, and that's it's
Look
pretty.
Look at that.
Yeah, it's pretty nice. And it's very shiny. Go ahead, pick it up, do whatever you want with it. It's very shiny from this angle. Now, if we were to look inside, and I know we can't do that with the camera, you would see it was a lot rougher on the inside because we're only seeing a couple of molecules, that are just adhering onto the surface, so it reflects the light.
Kind of crystallizing on the
well, in a way, yes, and it's reflecting the light completely at us. But on the inside, where it's built up several layers, it's not as nice. But and the cleaner your glass is, the smoother your glass is, the better mirrored surface you're going to get. So this is basically how they do it today. Still, well, if they're making a silver mirror, and a lot of places prefer silver mirrors as opposed to aluminum, because this is silver tends to be much more reflective than aluminum. The problem with silver is it will oxidize, and then eventually the mirror goes away. And aluminum doesn't oxidize as easily in these kind of conditions, so they last longer and
Very
much
cool.
less expensive.
Cool.
So this is how you will mirror surface. And like I said, you can do this.
Yeah, right. How's my makeup? Whoa! It's too good. Jesse, we appreciate it, sir, as
Not a
always.
problem.
Hey, this will be on IllinoisHomepage.net right after the morning show today, and we'll be right back.